Alright, we are ready to start a new unit here. We only got 3 units left in our life of geometry. And so this unit is the quadrilateral unit, and that's why I wrote this over here just so you know. But we're going to start out by learning about different types of shapes, which are polygons first. So far, we have only dealt with triangles. So a polygon it can be a triangle, but it's any shape with 3 or more sides. So hopefully that you have your note sheet ready, because you're just going to follow along with what I'm writing down. And so on your sheet, the first question asks what a polygon is. So a polygon is a shape with 3 or more sides. Also, it can't have any curves. And then the third thing is that none of the sides can intersect. So it can't have any vertices that overlap or anything like that. So no intersecting sides. So what we're going to do is we're going to take a look at different characteristics of polygons, and then we're going to learn about the degrees inside polygons. So the next thing is determining with these 4 shapes if they're polygons or not. So hopefully that you're looking at the first one and saying, yes, this is a polygon. This has 1, 2, 3, 4, 5, 6, 7, 8 different sides, and we'll learn about what that means. The second one, if you notice here, has curves. So this heart is not a polygon because it has curves in it and it can't have curves. The third one has intersecting lines right here. So this is also not a polygon, but it would be 2 polygons put together. So you could have 2 triangles, but the shape itself is not a polygon. And the last one, although this may look like it's not a polygon, there's no intersecting lines, there's no curves, so this is actually a polygon. And it's a special type of polygon, which we'll talk about next, which depends on if it's concave or convex. So hopefully you've heard of these words before, maybe in science class with lenses, but concave versus convex. So I'm just going to read through the sheet that you have. So a polygon can be described as having a convex or a concave look to it. And for a polygon to be convex, there should be no points or vertices in the interior of the polygon. And I'll explain what that means in a minute. You can also use the convex test that tells you to extend any side in the polygon, and it should not intersect with any other side. So again, the basic thing is it can't have any intersecting sides, so no vertical angles that are being created. So those would be what you would want to fill in the blanks. So an easy way to tell if your polygon is concave is when one of the sides is caved towards the middle. So in the 4 shapes that you have, the first shape that kind of looks like this, it looks like a cross maybe, like a hospital cross. This would be considered concave because this side right here, as you can see, is like being caved in towards the middle. All these sides right here are being, it's like almost someone took a punching bag and just punched it right in. So this is concave. Now the second picture that looks like a diamond, that is convex. All of the sides, all of the angles are pointed towards the outside. The third shape would be also concave because, as you can see, it also looks like someone took, their fist and just punched a box in. So this would be concave because it's caving towards the middle. And then the last one, which is a trapezoid that we'll learn about next, is a regular convex. So that's the difference between concave and convex, and we'll work on that more later. Alright, next is we're going to determine the shape by the number of sides it has. So hopefully this looks familiar to you, and if you flip on the back of the first page, there's a wonderful handy-dandy chart for you. You will be responsible for knowing the proper names for polygons up to 10 sides. So hopefully you know most of these, like a 3-sided shape is just called a triangle. Quadrilateral is 4, pentagon 5, hexagon 6, heptagon is 7 sides, octagon 8, nonagon 9 sides, and decagon 10 sides. So I'll give you a second to fill those things in. And then another way that you can name them is using the gon. So anything past 10, so for example if it was 11 sides, you would say 11 gon. or 38 sides, you would say 38 gon. So anything beyond that, that's how you can name it, but up to 10, you need to know the proper name. Now, you could name a decagon saying 10 gon, but I want you to know the proper name. It's good to know those prefixes. And it says regular here. I don't know if you remember what regular means, but regular means that all of their sides are equal. So regular means equal sides all the way around. And that's the first blank on the back of the first page. So equal sides all the way around. So basically is this triangle here, as you notice, all the sides are equal. This quadrilateral is actually a square, the pentagon. So regular means that all the sides have the same measurements. So looking at those pictures that I have for you on your example sheets, hopefully you're saying that the one on the left, this shape, is not regular, because you definitely can tell this side is shorter than this side. But then the second shape, which definitely I drew it perfectly, I know. But this is regular because they are equal all the way around. So if you notice, though, these are both six-sided shapes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But the top one is an irregular polygon, and this one is a regular polygon, or an irregular hexagon and a regular hexagon. Okay, next thing on the sheet is naming a polygon. So naming a polygon, we're not going to spend a lot of time on this, but if, let's say, you had a nice rectangle like this, and I wanted you to name this, you would name it by saying rectangle A, B, C, D. It doesn't matter the order that you put the letters in. You could say rectangle B, C, D, A, but you have to name them in order, like either clockwise or counterclockwise. So you have to go like A, B, C, D. Or, like I said, you go B, C, D, A. But you can't hop all over the place and say A, C, D, B. Okay, they got to go in some kind of clockwise or counterclockwise order. I'm going to have you skip the second picture because we're not going to deal with anything crazy like that. Let's move down to how to name these things. So let's say that you have this polygon W, Z, X, Y. So there's three main parts of polygons that you need to know how to name. And the first one are sides, and the second one is vertices. And if you don't know what vertices means, the singular version for that is vertex. So vertices is just plural for vertex. And then the third one is the angles. So in this shape, the sides would be, again, naming them sides are using a segment, so side WZ, side WX, side XY, and side YZ. Okay, so this is a quadrilateral, so you have four sides. Now the vertices are the vertexes of all the angles, or the points. So all of these here are all your vertices. So you have four vertices, which would be point W, point Z, point X, and point Y. The angles then are the actual angles. So all the angles, there are four angles right there. And the only difference here, sometimes you may have to use three letters, but I'll let you use one right now. So it would just be at angle W, angle Z, angle X, and angle Y. So if you notice here, the neat trick about this is that however many sides it has the same number of vertices and the same number of angles. So you know that if you had, let's say, a 25-sided shape, it would have 25 sides, 25 vertices, 25 angles. Everything matches. Okay, let's go on to the last thing on the last page. So we're going to go through some of this chart, but not all of it, because it's a little complicated, but I think that you can handle it. So what we're going to do is figure out the degrees inside of a polygon. So if you notice on your chart there, you have the number of sides. So we're going to talk about first just sides 3, 4, and 5 so you understand. So what it's saying there is that if I have a triangle, so I'm just going to draw a triangle here. A triangle has three sides, right? Good. So in the triangle here, there is one triangle, and the inside of a triangle is 180 degrees. All right, so remember that. Now let's go to a four-sided shape. So a four-sided shape, let's go with the square. So if I took the square and I made triangles out of it, the least amount, and I drew a line just like that, how many triangles do I have there? I got 2. So each one of these triangles measures 180 degrees. So that means that inside of every quadrilateral, every four-sided shape, you're going to have 360 degrees because there are two triangles in every quadrilateral. Now, what about a pentagon? So let me try to draw a pentagon. These are kind of tricky. So here's your pentagon, five-sided shape. So if I drew, again, from one vertex, I have three triangles this time. So each of those triangles has to add up to be 180 degrees. So 3 times 180 gives me 540. So inside a pentagon, there's a total of 540 degrees. So as you can see, each time that you add a side, you're adding 180 degrees. Now, the formula in there says that, so let's say I had 8. So let's bounce up to 8 different sides. So if I had 8 sides, what they're saying is I take 8 and I subtract 2, and that will tell me the number of triangles. So there's 6 triangles inside every 8-sided shape, which makes sense here because 4 minus 2 gave me 2, 5 minus 2 gave me 3. So I have 3 triangles, 2 triangles, so forth. Okay, the 10-sided shape then, how many triangles would be in the 10-sided shape? 8. 10 minus 2 is 8. So then what you have to do is you have to go back, and now we want to figure out, well, how much is just one inside angle? So inside of a square, there are 4 total angles. So you would take the 4 total angles, there's 360 degrees, so you would divide the 360 degrees by 4, and that gives me 90. So that means each angle on the inside is 90 degrees, and that makes sense. Now for the 5-sided shape, I have 540 degrees, so I'm going to divide that by 5, and then when I divide that by 5, I get 120. So that means each angle inside this pentagon is 120 degrees. And that makes sense. They all look obtuse, right? All right, let's do the 8 one. So the 8 one, I need to do 6 times 180 degrees, because that is 1440. Then I would divide that by 8, because that's the number of sides, and I would get 135 degrees. So in each 8-sided shape, there's 135 degrees. We will save the rest for later. So you just hold that thought, and we'll finish the chart in class.